I've been deep in the terminal lately, really exploring system performance. But how well do we actually understand the tools we use every day, especially when things go wrong? Today, I'm challenging you with 7 tricky Linux quiz questions, all about the tools you need for monitoring and debugging disk I/O. These are real-world scenarios, the kind you'll face when your server is crawling and storage is the suspected culprit. Lock in your answers as we go, and let's see if you're a true Linux pro or if you'll learn something new. Ready? Let's get started. Alright, let's dive deeper into interpreting IOStats output. First question. Let's say a command which gives you extended statistics updated every 1 second, which is crucial for real-time monitoring, and you immediately see the %util, or column, that is near 100% for one or more of your disks. This is a key indicator, and it's telling you something important about your system's performance. What does this mean? Let's test your understanding with a quick quiz. A. Disk is full, meaning you've run out of storage space. B. Disk is saturated with I/O, meaning it's struggling to keep up with the read and write requests. C. Disk cache is full, indicating a problem with the disk's internal memory. Or D. Disk is about to fail, suggesting a hardware issue. The answer is B. The disk is saturated with I/O. The disk is processing I/O requests 100% of the time, leaving no room for new requests without delay. It's saturated. This means applications are waiting longer to read and write data. High %util means the disk is busy every moment of the interval, constantly working. So new requests queue up, causing slowdowns and impacting overall system performance. Don't confuse this with disk space, which is a completely different metric. Use for that. That command will show you how much storage you have left. High utilization doesn't necessarily mean imminent failure, but it does warrant further investigation. But chronic saturation is a red flag, indicating a potential bottleneck that needs addressing. The key %util is about time spent working, not space or health. It's a measure of how busy your disk is over a given period. If you see 100% consistently, your storage is the bottleneck, the slowest part of your system, holding everything else back. Time to investigate what's hammering the disk and causing the high utilization. Is your first clue in the performance puzzle, helping you identify the source of the problem. 1 down, 6 to go. Next, you check the disk statistics using the command. This command provides a detailed view of disk performance, allowing you to identify potential bottlenecks and areas for optimization. It's a crucial step in diagnosing storage-related performance issues. After running the command, you examine the output and see an await value of 50.00 for one of your disks. This value represents the average time in milliseconds that I/O requests spend waiting to be serviced by the disk. Now the critical question arises, what does this mean for your system's performance? A. Does it indicate 50% disk utilization, meaning the disk is operating at half its capacity? B. Could it mean 50 microseconds per request, representing the time each I/O operation takes? C. Is it 50 milliseconds average I/O time, encompassing both the time spent in the queue and the actual service time? Or D. Does it signify 50 IOPs, meaning the disk is performing 50 input-output operations per second? The answer is C. Await shows the average time in milliseconds that each I/O request spends waiting. This includes the time spent in the queue, waiting for its turn, and the actual service time, when the disk is actively processing the request. A high await value indicates that your applications are experiencing delays and waiting longer for storage access. This directly impacts the overall performance of your system, leading to sluggishness and reduced responsiveness. Don't mix up units. It's milliseconds, not microseconds, so pay close attention to the scale. Remember that utilization and IOPs are valuable metrics, but they are presented in other columns of the output. Think of await as your total wait in line time, the cumulative delay experienced by I/O requests before they are processed by the disk. If await is consistently high, exceeding acceptable thresholds, it's a clear indication that your storage subsystem is becoming a bottleneck, slowing down the entire system. This metric provides a strong justification for considering upgrades to faster storage solutions, such as SSDs, or optimizing your application workloads to reduce I/O demands. Therefore, always check the await value when troubleshooting applications that exhibit laggy behavior or slow response times. Now that we've clarified the meaning of await, let's move on to the next important concept. Assuming your disk is busy, which process is to blame? Which tool shows real-time per process I/O usage? A. IOStat. B. IOTop. C. VMstat, or D. DF? The answer: B. IOTop. IOTop gives you a live, sorted list of processes by I/O usage, perfect for finding the culprit. Other tools show open files, system-wide stats, or process lists, but not live I/O per process. With, you go straight from "the disk is busy" to "this process is the problem," essential for any sysadmin. Next, you suspect a performance issue involving disk, CPU, and network. Which tool gives you a real-time, all-in-one view? A. ITOP, B. SAR, C. IOStat, or D. DStat? The answer is D. DStat combines CPU, disk, network, paging, and more, side by side, updating live. It's perfect for spotting correlations like disk spikes matching network or CPU weights. Other tools focus on one area. DStat shows the big picture. It's like a dashboard for your whole system. See a slowdown? Instantly check if it's disk, network, or CPU. For complex issues, DStat is your go-to. It's perfect for spotting correlations like disk spikes matching network or CPU weights. Other tools focus on one area, shows the big picture. It's like a dashboard for your whole system. Let's keep going. Next, using the ATOP command, a powerful system monitoring tool, we can gain real-time insights into system resource usage. You sort by disk activity, pressing D will change the sorting parameter, and see a process with high disk utilization, indicated by the DS key value, but zero read disk and write disk activity. This is quite strange, isn't it? What's happening under the hood? What could be the root cause of this anomaly? A. Reading directly from the cache, bypassing the disk. B. A kernel thread issue, perhaps a deadlock or resource contention. C. The process is stuck in uninterruptible sleep, D state, waiting for I/O, or D. A bug in the ATOP tool itself. The answer is C. The process is indeed stuck in D state, a state where it cannot be interrupted, waiting for a disk I/O operation to complete. But it's not progressing. Shows the time spent waiting for I/O operations. If reads and writes are consistently zero, it indicates that nothing is completing, a classic sign of an I/O block. This often signals a slow or unresponsive disk, a problem with network storage, or a deeper system issue. Cache reads wouldn't typically cause this specific behavior, and while software bugs are always a possibility, this particular scenario aligns with a well-known diagnostic pattern for I/O bottlenecks. Seeing this pattern is a major red flag, a clear indication that something is seriously wrong. The process is fundamentally stalled, blocked by the storage subsystem. Check your hardware, especially the disk or network storage infrastructure, immediately to identify the bottleneck. Reveals not just the I/O weight, but also the direct impact on individual processes, allowing for targeted analysis. Powerful insight for effective troubleshooting and rapid problem resolution. True or false can show the size of each I/O request to a block device, helping you spot inefficiently small I/O. The answer? True. Traces every I/O event at the kernel block layer, including request size, process, and operation type. This lets you find apps writing tiny, inefficient chunks, like 512 bytes at a time. With this info, you can tune app buffers for bigger, more efficient writes. It's not an everyday tool, but it's invaluable for deep dive storage troubleshooting. When you need to optimize at the lowest level, is your friend. One last question. Last one. You're using DStat and see high reads on your disk devices. Which DStat option shows the process causing the most disk activity? A. CPU, B. Top IOC, BLEC, or D? Max? The answer: A. Add this flag to see the top I/O consuming process live right alongside your system stats. No need to switch tools. See the what and the who in one place. Shows CPU, not I/O, isn't valid is for block I/O, but is the go-to. This feature bridges system-wide and process-specific monitoring. Perfect for fast, focused troubleshooting. And that's the quiz. We've covered everything from saturation metrics to low-level I/O tracing. Mastering these tools sets you apart as a Linux pro. Let's see how you scored. So how many did you get right? 6 or 7? You're a Linux I/O legend. People rely on you when things go wrong. 4 or 5? Solid foundation. Keep practicing and you'll master it. 3 or fewer? No worries. Showing up to learn is what matters. Every expert started as a beginner, and now you know where to focus next. Share your score in the comments, and subscribe for more Linux mastery quizzes. Thanks for playing. See you next time.